Measuring systems, thanks to those crazy Americans. The most sensible system in the world is the metric system. Okay, so we'll be looking at that. Now there's two different types. Ours is the SI. I don't even know what the other type's called. I just know there are two types. It's a base 10 system, which means decimals are used. So if here's your decimal value, your decimal place, you're going to multiply it by groups of 10 to move your decimal to the left, or you will divide it by groups of 10 to move your decimal to the right. Your numbers or your digits won't change until you round. And compare that to the American system. That's the imperial system. Okay, it's also what's used in Britain, so it's not just America. It's a fraction-based system. So inches are out of 16. Sometimes you'll measure inches out of 32 if you want lots of accuracy. And then you can use what we're going to find are called vernier calipers. So some can measure out of 64ths, and if you're super duper accurate, 1/28. But for a common ruler, it's out of 16ths, which can be reduced to out of 8ths and out of 4, right? And don't forget halves. So you can have half an inch, a quarter of an inch, 1/8 of an inch, 3/8 of an inch, 3/4 of an inch. How much is 4/4 of an inch? 4/4? 1 inch. Just checking. Okay? All right. We'll be talking more about that in the next couple of days and exploring it more. Jazz, I really like my chairs, and students don't want to sell broken ones. Thank you. Okay. When converting from metric to imperial, you're going to have to convert into fractions. So let's do this a little bit. 7 3/4. What is that as an improper fraction? So 7 times 4 is 28. And then 28 plus 3 gives us our new numerator of 31. The denominator doesn't change. Okay. So 7 times 4 is 28, so 7 groups of 4. Okay, for B, you have 5 groups of 12. So what is that fraction as an improper fraction? Convert it. 67? And the class says yes. Good. Moving on. Going the other direction now. Now it's how many groups of 8 are in 37? Okay, so guess and check. This is non-calculator. Non-calculator. Okay, I think there's about 4 groups of 8. Now 4 times 8 equals 32. So I would simply subtract 32 to see that there are 5 8s remaining. Okay, so 4 whole groups of 8, 5 8s remaining. Try that for B. Go. So 83 over 12. I think there's 6 groups of 12, which is 72. So I subtract 72. And you'll have 11 twelfths remaining. Okay, so we have to convert the following into mixed fractions. Note that the inches can be split into 16ths. Okay, so what we have here is we have a whole number, which is 8. And we have to figure out how many 16ths are remaining. So we take our decimal. Right? We're not worried about the whole number. We already know there's 8 inches. So we take our decimal and we multiply that by 16 to figure out how many 16ths that is. So 0.95 times 16 equals 15.2. So this is approximately 15. So we have 8 and 15 over 16. Okay. So you take your decimal, multiply it by the denominator to figure out how many 16ths that is. So the next one, how many whole inches do you have? 6. And what are you going to do with your decimal 0.388? Yeah, multiply by 16. Okay, so write that down. Don't call it out, please. Let everyone try it. Watch your rounding. And you get 6.208. So we're not worried about the 0.208. Okay, so this is going to be 6 inches and 6/16. Now we shouldn't have 6/16. We should put into lowest terms. So what can we divide by? 2. So divide them both by 2, top and bottom, and we're going to get 3/8. Okay, so 6 3/8. We just covered a lot of stuff there, right? If you measure in decimals, you got to convert to inches, which means it's got to be out of 16ths for the leftover part. Plus, reduce your fractions. Always reduce your fractions. Okay? Any questions? Kind of nice trick with the whole number, isn't it? Being the whole number of the fraction. Okay, we just have to convert the decimal into 16ths. All right. Height. So, height's often expressed in feet and inches. Remember, there are 12 inches in 1 foot. So, for example, if you have 5 feet 5 inches, that would be 5. You have to convert that into inches. So it would be 5 feet times 12 equals 60. So altogether, you have 65 inches inside there. Okay. We'll be covering that a little bit more, but it's always good to be able to convert back and forth. So now we have 12 inches in 1 foot. So if we have 5.416 feet, how many whole number of feet do we have? 5. How many inches though? So now we're going to take our decimal, and we're not multiplying by 16, but we're multiplying by 12. So we got to convert it into inches. And so we get 0.4167 times 12. That's going to be 5 inches. So we put them together. We don't write this as a fraction. Like technically, we can write it as 5 over 12 feet. But that's not proper. So instead, you don't write 5 over 12. You write it as 5 inches. Okay, 5 feet, 5 inches. Try the next one. How many whole feet do you have? 9 feet. Okay. So take the 0.273, times it by 12. And you get 3.276. So approximately how many inches do you have? Yeah, 3 inches. Now, if you really wanted to get crazy, now this is a large measurement, so it's not a big deal. But you could, though, convert the 0.276 times it by 16. So 0.276 times 16, and you're going to get 4/16. So you could get 3 inches and 4/16, which is 3 1/4. Nope, because what we're doing is looking at the inches, which is 16ths. So we go from feet to inches. Now that's way beyond, that's more than what we're doing, okay? So the answer I'd expect is 9 feet 3 inches. But that 1/4 of an inch, that would be something you need to know if you're actually going to cut a board. Otherwise, you measure twice, cut once, right? You're going to be going by another piece of board. And that sucks, as I know many times, over and over. Wife hates that. Just to let you know. Okay, any questions? All right, so we don't need the accuracy of the 1/4, just to let you know. That's a little bit above and beyond. I'm just going to erase it so you guys don't worry about that. Okay, turn it over. A little bit of Pythagoras for us. So a couple things to remember. No decimals. Unless someone specifically says 2 decimals or 3 decimals or 1 decimal. So unless requested. Otherwise, you're going to leave it as a square root or maybe like x root y. Okay, as a radical. So no more decimals. decimals are just an approximation, whereas leaving it in this other format that we just learned is an exact value. Okay. So keep in mind, you have a right triangle. C is your hypotenuse. And what do we know about our hypotenuse, which is really important? It's the longest side. Okay? That's super important. It helps you stop making a mistake. Now here we have A and B. Those can switch. It doesn't matter which one's A, which one's B. Those are what we call a leg of the triangle. Okay? No leg can be longer than the longest side. Keep that in mind. So our formula is c squared equals a squared plus b squared. I always write it this way because it's easier to work with. Or if you're trying to find a leg, you'll start with a squared and the formula rearranges to c squared. Oh, but then you wonder, should I add or should I subtract? Well, think about it. You know the longest side c. If you already know it and you know it's the longest side, don't add to make something longer than the longest side. So you subtract. Okay? If you know the longest side, don't make something longer. Okay? All right. So your triangles aren't going to be easy anymore. You're going to have to do double Pythagoras. So it's not just 10 and 12 to find this value. You have to go 10 and 12 to find this value y. But then you have to use y and 8 to find x. Aha, a little bit trickier. So let's start with y squared. 12 squared is the hypotenuse, so should we add or subtract? No, we don't want to add to making something longer than the hypotenuse, so subtract. So this is non-calculator, please. So y equals square root 44. So now I'll work in blue. So we're still using the same y, but we're using the other triangle. So we're going to get x squared equals y squared plus 8 squared. So we're finding the hypotenuse now. Okay. So x squared equals square root 44 all squared. That's kind of cool. What happens there? When you square a square root, it cancels out to 44. That's awesome, Mr. Barker. I know, it's pretty cool. Welcome to grade 10. Okay, so 44 plus 64 is 108. So x equals square root 108. And now you have to simplify. No decimals, no calculators, you have to simplify. So 108 divided by 2 gives you 54 divided by 2. Keep going. Let's go. See if you can take anything out. $27, 3, and 9, 3 and 3. So you can take out a group of 2 here, a group of 3 there. So this equals 2 times 3 square root 3 that's remaining. 6 root 3. Okay. Total test question tomorrow, right? That's absolutely on there. Okay, so you're welcome, Andre and Alan. You're welcome. All right. You don't have to look for the exact question. It's just the idea. Okay, guys, any questions? Do we use a calculator? No. Now, if you get something big, yeah. Okay. Number 2 is no calculator. Let's have some fun. All right. X squared. Should I add or subtract? What should I do? Keep in mind your hypotenuse is across from 90 degrees. Root 75. So root 75 squared minus root 50 squared. Now you can use brackets if you want. It's the same thing. So x squared equals 75 minus 50. Right? The square and square root cancel. Oh, this is looking easy. What does x squared equal? 25. So then we have to square root them both. Oh, what does square root 25 equal? That's a perfect square. Equals 5. Okay, so once in a while you get a perfect square. Once in a while, very rarely. Like maybe, 3 times in a year, 4 times in the year. Okay. All right. Thumbs up down in the middle. Okay, you guys are awesome. There we go. So this one's a little bit different. You haven't seen this before. What do you guys think you should do first? Convert. Okay, so you want to convert. So this would be square root of 5 times 5 times 3. Now go to your calculator. This is getting a little bigger. 7 times 7 times 5. This would be 75. This would be square root. Oh, watch this. Mental math. 7 times 7 is 49. Now what's 49 times 5? Well, 50 times 5 minus 5. Right? 50 times 5 minus 5. Same thing. So 250 minus 5, 245. Well, you can do some of that mental stuff in your head. Pretty cool. Yes, I know. Okay. But I do this all the time, right? So, otherwise, go to your calculator, get the answer. Now I'm going to sell that, give myself some more space. Okay, find x. Go for it. Let's see what you can. Okay, so x squared will be root 245 squared. Make sure the square root covers everything. Minus root 75 squared. What does x squared equal? 170. So x equals square root 170. Can you simplify that at all? No, not at all. Okay. Very quickly you realize here, right? You take 170, divide by 5. What is that? 34. Divide by 2. What is that? 17. Okay, so there's nothing you can take out. So always check, though. There's nothing you take out. All right. Now, this is the bread and butter. This is the classic. Star it. They love this question. Okay. What we call this the super hypotenuse. That's what I call it. Or the super diagonal. Diagonal. I can't spell. Okay? So you're working on 2 dimensions, 2 planes. So what we have here is 2 different triangles. We have this one triangle. Don't draw this, just watch. We'll call that C. So this triangle here is at the front of the box. Do you guys see that one? Okay. Then sideways you have another triangle that goes into the page right here. Kind of goes into the page. Do you guys see that triangle? Okay. So what we have to do, there's this line AC that connects them. So if I drew it like this, we'd have to find AC. Then we can use AC and 3 to find AB. Now notice on this other triangle, here's your 90 degrees on the bottom corner. Okay, even though the triangle's tilted up, that's still 90 degrees. You guys okay with that? Hands up if you see it. You don't have to. Not everyone's going to see it. Okay. So now that's one way you can see it. Now here's the other way. You can draw the triangle on the bottom with the 5 and the 3. So this here is a triangle on the bottom. Hands up if you see that. Okay. And then this triangle here is 90 degrees. There's a triangle going into the page here. Can you guys see that one? Okay. There's a couple different ways of seeing that. But notice what I did is I shaded them. If you're stuck on a test, shade your triangles. That may help you. Okay. And then what we can do is we can find BC here, because that's what connects the red and the blue triangle, this line right here. Okay. So let's work with this one because I drew it last. Please draw that and label that side C. Go for it. Okay, so draw your lines, do your light shading, maybe shade in different direction if you want, okay? If you don't have two different colors. And I want you to do your math to figure out what BC is. Now don't go, just find BC squared. Anyone know why I just leave it as BC squared? It's a little less work, right? Because the next question you're going to need BC squared. Okay. So now what I want you to do is find AB. I should change that color. This should be red. There you go. And then this one should be blue. Okay, so now I want you to find AB. So AB squared equals BC squared. Oh, BC squared, you know what that is, plus 2 squared. So now you're finding the hypotenuse again. So you're finding the hypotenuse and then finding another hypotenuse. Okay. See if you can square root that any further. No decimals, but see if you can if you can break it down into a mixed radical. Can you break it down any further? I'll give you some more time. Excuse me, sorry, that's your final answer. Any questions? So we kind of took Pythagoras to a different level here, didn't we? All right, just a step up. We're going to do some more and more practice of this, and we're going to do lots of questions with it, okay? So you guys should be experts at this. If at all, any questions at all, you've got to ask, you've got to know Pythagoras. New thing out called the internet. You can use that to find information. There's something called Google. Like, you can find tons of stuff on there if you didn't know, okay? But seriously, you need to know, okay? Absolutely. At least someone's finding that funny. Okay. Perimeter. Perimeter of a rectangle. Here's the length. Here's the length. Here's the width. There's the width. So this formula is a shortcut for length plus width plus width. Okay? So there's 2 of each type. That's why it's 2L plus 2W. So you can even shortcut it even further by doing this. Okay, adding them together, then doubling them. Area you should know, length times width. Perimeter, no problem, but expect to have to do Pythagoras to figure out a dimension for perimeter or for area. Sometimes not, only one of them, sometimes for both. Okay, so it's not just plug into your calculator and barf on the page. You actually have to do a little bit of thinking to figure out what some measurements are. Circle's pretty good, C times D, although this is the one that's more common, and we're going to have you working backwards. So we'll give you the circumference, and you have to find R. Area, pi r squared. Any questions? All right, let's roll. Turn it over. So, to find the perimeter, you got to add up all the sides. It's like the fence around your yard. Now keep in mind, this is 5, this distance is 7. What is this entire distance then? Who said 13? 12. Chris. Okay, so yeah, you add them up. So sometimes you're looking at other measurements and adding them up. So it'd be 5 plus 7. Now, keep in mind, this whole distance is 20. This little distance is, well, what is that little distance? Yeah, same marking, so it's also 5. So the whole thing's 20 and that little one's 5. What does this distance have to be? How did you get 15? 20 minus 5. So sometimes you're going to have to subtract to get measurements. Got to be a detective sometimes. Okay, find the perimeter. Go, add up all the sides. So what's the total of the perimeter? 64?
Yep.
And that's going to be centimeters, okay? It's a linear unit, so it's not squared. Now notice how it's almost like this side could extend out to here, and this side could extend out to there. Okay, so your perimeter really could also be simply 2 times 20 plus 2 times 12, right? 40 plus 24. Okay, works out for this shape. Don't worry about it though, not a big deal. Okay. All right, area. So for the area of the total shape, you have to divide it into 2 separate pieces. This could be piece 1, this could be piece 2, or you could divide it this way and piece 1, piece 2. Your choice. I'm going to use the blue division, but you just have to divide it up any which way. Be careful how you do it. Okay. Go for it. Find the area. So length times width plus length times width. Make sure you're using the proper dimensions when you're multiplying. It's 135 centimeters squared? Yep, good. Okay. So, next, circumference equals 2 times pi times r. Remember, r equals diameter divided by 2, and the diameter equals 2 times the radius. Okay, those are 2 that you need to know sometimes. I'd write them down there. So here, circumference equals 2 times pi times 5. Quit playing footsies. C equals 10 pi. Done. So just multiply your numbers. Leave it as a multiplication. 10 times pi. Don't go to a decimal. We want to deal with the exact answer. No decimals. Okay. Don't have to use the pi button on your calculator. We're done. If you had a shape other than circles, though, then you'd go to decimals. Okay, anything other than circles put together. Area, go for it. Pi r squared. Okay, so this would be pi times 5 squared, 25 times pi. This would be meters squared. This is simply meters. Okay. Don't need to go to the decimal, but if I did, what operation is it? Add, subtract? No, it's multiply. Okay, so it's like 25 times pi. Okay. Thumbs up, down in the middle. What do you guys think? Okay. Next one. All right. Define area. Easy peasy, lemon squeezy. Base times height divided by 2. Base and height join at 90 degrees. Okay. So you're looking for your 90-degree symbol. Substitute in. Area is 7 times 24. Divide by 2. I divide 24 by 2 first to get 12. And 12 times 7 is 84. So what you think is a calculator question really isn't. Okay. Now this is great. Can you find the perimeter? Not at all. You have to find C first. So go ahead, do Pythagoras. Go. This is a calculator, like 24 squared. That's a high one. Okay, find the perimeter. Go. So perimeter is going to be 7 plus 24 plus 25. Simran, what is it? Alex, what is it? Simran? Who's got it? Someone? Okay. Just shout it out. Who cares if it's wrong? I don't. 56 meters. And it's right anyways. Okay. Any questions? Yep. You got 31? Oh, but you forgot to add the side here that we had to find using Pythagoras. Okay, so you got to find all three sides, not just two. Okay, volume for a rectangular prism. The volume from the formula sheet is the base area times the height. Now this happens to be a rectangular base. The formula for a rectangle is length times width. So they're not going to give you the formula, but you have to come up with the formula, length times width times height. Okay. Keeping in mind that length times width is there because it's a rectangular base. Now the 6 is up top, but remember you can write the 6 below, and then it's maybe a little bit easier to see your rectangular bottom. Okay. Or you can even move the 2 up top if you want. Right? Don't hesitate to move numbers around. Put them all over your diagram, folks, all over the place, and move them, well, where they belong. Okay. So it'd be 6 times 2 times 10. 120 units cubed.